if this distribution is of a binary random variable x, where x can only be 0 or 1. We need to find the expected value, the variance, and the moment generating function, or the binary distribution. If you check here, this shows us that this type of the distribution has only two possible outcomes, either a success or a failure. But anyway, we are interested in finding the expected value, the variance, and the MG head of this distribution, or rather may I say, deriving this. So let's begin with the expected value. So what do we find the expected value of the binary distribution? First of all, we just need to write the formula for the expected value, which is that, which is x multiplied by the distribution. But in this case, we have the binary distribution. So from here, because we know that we are starting from 0 and we're ending on 1, so to get the expected value, what we are going to do is just to sum up x, 0, and x1 like this. 0 multiplied by the distribution here. In this case, it's the binary distribution. We will have p of 0 because here we have indicated 0. So we assume in this case our x is 0 everywhere. So like that. And plus, because we're summing up, we still have 1. So we will have 1 multiplied by, sorry, let me just write, p here of 1, and we'll have 1 minus p, 1 minus 1 like that. Let's go on and try to complete this. Let us start here. The whole lot of this term is multiplied by a 0, and anything multiplied by 0, we just have a 0 here, and we have a plus. Anything multiplied by a 1 like that is just the things here. So let's concentrate on the things we have here. So when we subtract there, we're getting a 0, and 0, any number I mean raised to power 0, it's just itself. I mean it's just a 1, rather, not itself. So here we're getting a 1, so it will be p raised to power 1 is just itself. Then there will be multiplied by 1, and the conclusion to this is just a p. So this is our expected value of the binary distribution. How about the variance? Let's go on and get the variance. So the variance of x is given by expected value of the second moment minus, I'm supposed to write minus here. So we have expected value of x squared, like that. We know this, but we don't know this yet. So let's go on, first of all, compute this. But how do we compute this in this case? Well, what we need to do is just to square the x values that we have. It's 0 there squared, that's 1 squared. And we will have 0 squared, or like writing the formula. So let me just write the formula here as well. So I'll say the summing up for x by x squared multiplied by the distribution we have that. So this is, let's do it there. So we will have, summing up that, we will have 0 squared of p, 0, 1 minus p of 1 minus 0, like that, multiplied by, I mean, a lot of mistakes in this. It's too easy, maybe. Yeah. So fast because it's too easy. Well, let me take my time. So we are summing up. It's a plus 1 squared. Then we'll have p, 1, 1 minus p, like that. Then we'll have 1 minus 1, like that. Hope you guys are able to see. So here will be, this term will be just a 0. So it's a 0 as usual. I've seen, guys. Wow. It's not always the case, I think. Not in all the distribution. But anyway, whatever 0 is concerned when we're multiplying by 0, we just need to get it 0. 0 is so selfish. Well, let's proceed. So here, 1 squared is just 1, and 1 multiplied by anything is just those things. So we concentrate here. And here, 1 minus 1 is just a 0. Any number raised to power 0, we have a So here we will have a 1. And this p raised to power 1 is just a p as itself. So notice that even here we're getting a p. So this is the second moment equal to p. So now we have everything that we need to compute the variance. Let me just rewrite the formula. Rewriting the formulas. Follow what is being done. So squared, here we have a p minus here as well as p, but we are squaring it to be squared like that. So if we compute that, we'll have p minus p squared. We're almost there, but we just want to make that look very smart. So what we are going to do is we're going to just factorize a p. Let me just hear this one. I'll take a moment, maybe just seconds hearing this. So the same variance is equal to p minus p squared. So we are seeing that p is common, so we factor it out, remaining with a 1 here. We'll have p right there. Looks very smart. So this is the variance of the Bernoulli distribution. How about the MJF, the moment generating function of the Bernoulli distribution? Let me just lab this. So the MJF will be m of x t is a ring of tx. Well, this is the MJF. So to sum up this will be summation of all this e of tx multiplied by the distribution that we have, which is just the Bernoulli distribution. So the same way, we're going to say x is 0, first of all, it will be t of 0 there. Then this distribution, we use that, and this will be 0, 1 minus p, 1 minus 0 like that, plus, and we will have e again of ln of 1, then we will have p of 1, 1 minus, so minus p, 1 minus 1, like that. Yeah, what we are going to have is 0 multiplied by t will be a 0, so we will have ring of 0, any number raised to power 0 is just a 1, so we will have a 1 there, multiplied by this number will be a 1, then we will have 1 minus, let me write it well. So here we will have 1 minus p, 1 minus 0 is just the 1, and have it like that. Then we will have plus this 1 multiplied by t, we will have ring of t. Then in here, when you subtract that, we'll have a 0, so this is 10, this is a 1. Then we will have a p raised to power 1, just a p. So p multiplied by a 1 there, we will have just p multiplied by this 10. So what are we going to do here? Just create space here, it up here, and compute the MGF. So we will have m of x t is equal to, if you come here, this is a 1 multiplied by that, it's just a thing inside, and again we have the 1 multiplied by that, so we are remaining with 1 minus p just, then we will have plus, this will be p of a to the t, ring of t. So we will have 1 minus p plus p ring of t like that. But again, here, we said this has only two possible solutions, probability of success, which is p, and AQ, which is the probability of failure. Or in other words, for failure, we can say is equal to 1 minus p, like that. So this is what we have here, the 1 minus p. So to make it look very smart, you can just replace that by q, and we'll have p of a t. From here, there's nothing that we can do. So this is our MGF or Bernoulli distribution. So that's it for this video. Thank you for watching. See you in the next upload.